Okay, welcome back. This is the third session of this class. Very sorry, I have to be doing this in bits to make it easier for us to all grab efficiently and effectively. Though, yeah, let's just continue. As we've said so far, when you're asked to give the IUPAC nomenclature, you don't just give the common names. Right? You don't just give the common names. Now you might have some question that why is this 5? You might say why is this 5? Why is this 4? And why is this 4? Why is this 5? And why is this 6? If you need me to make clarification on these, you need to comment on the make a comment, send a comment to the platform, and I will respond to that by making a different video. It's totally something different which is not on the scope of this class for today. So there are explanations to that, but our class is going to fully be dependent on these. When you're asked to give the IUPAC nomenclature, I said you should call this hydrochloric acid. This should be hydrogen tetrasulfate 6 acid, and this should be hydrogen triazonitrate 5 acid. This should be hydrogen triazocarbonate 4. Yeah, then this is hydrogen tetraoxosulfate 5. Then you have hydrogen triazosulfate 4. So that's what is expected to be. However, these are the common names as used in most textbooks. Remember, we discussed about the classes. Now we're talking about the types of acids. The way you have two classes of acids, we also have two types of acids. Now these types of acid include, these types of acid include, we have the strong acids. We have strong acids and we have the weak acids. What does this term imply? When you say an acid is a strong acid, it means that acid ionizes completely in water. It ionizes completely in water to give its hydrogen ion and anions. Now basically I wouldn't like you to overburden yourself with lots of definition. What you just do is this: when you are asked about a strong acid, you just make a simple comment. A strong acid is an acid that ionizes completely in water. It ionizes completely in water. That is enough. It is enough to give you the required score or grading that is expected of the teacher awarding to you. You get it? So a strong acid is an acid which ionizes completely in water, while when you talk of a weak acid, it ionizes partially in water. Strong acids ionizes completely in water. Weak acids ionizes partially in water. And this is why we said that to give its hydrogen ion, remember we said an acid ionizes in water to give hydrogen ion or hydronium ion or proton. Good. So for strong acid, they actually give high concentration of hydrogen ion. They normally have high concentration of hydrogen ion. They have high concentration of hydrogen ion. Strong acid. For instance, you might be asked which of the following acid has a high concentration of hydrogen ion, and in that case you are expecting the answer to be what? Strong acids have high concentration of hydrogen ion because they ionizes completely in water. Then weak acid have low concentration of hydrogen ion because they partially ionizes in water. These are basically the two types. I come again, do not mix it up. Classes and types. The classes are the organic and the inorganic, and the types, you have the strong and the weak. Moving further, okay, I actually made this page for a perfect explanation. Now when we talk of strong acid, let's take for instance HCl. These are the major strong acid. You also have H2SO4. I'm writing it big so that you see it very well. And you have HNO3. Don't mind me, I'm using the mouse, and you know how it works. So now look at these three: hydrochloric acids, H2SO4, HNO3. Let's look at something. Now can you see this? I told you inorganic acids, right? These are the inorganic, and those are all what I just mentioned. So it means that most of the concentrated acids, or most of these acids, are strong, because most of inorganic acid, they are strong acid. These are the major three strong acids we have. Major three, take note. I'm not saying this is all. Major three strong acid. Now remember I said strong acids ionizes completely in water. They ionize completely in water. What does this statement mean? It's not, it's not too big. It's trying to tell us that when you mix these acids in water, all the hydrogen ions are separated. For example, HCl, when you dilute it in water, it's going to separate the ions into hydrogen ion, H+, which is kind of attached to the chloride ion, Cl-. We call it complete ionization because you can see that there's no more hydrogen attached to this chlorine. Likewise, for H2SO4, you have two hydrogen ions formed completely. Then you have SO4 2-. This is what we call complete ionization. Why? Because the hydrogen is completely separated. There is no more hydrogen attached to this. As you can see, there's no more hydrogen attached to this. So this is what we call complete ionization, and these are strong acids. For the last one, you also have the hydrogen ion, because we have just one hydrogen ion, NO3-. Remember, you can see the charges are balancing themselves. Here you have plus, you have two of these, that's 2 plus and 2 minus balancing. You have -1, you have +1 balancing. These are strong acids because there is a complete ionization. The hydrogen is separating completely. No, go back. Wow. The hydrogen is separated completely from the anion. You can see this is complete separation. But let's take an example. Let's talk about ethanoic acid. If you have ethanoic acid, I'm going to manage this because ethanoic acid is H3C COOH. So this is a weak acid. This is an example of weak acid. In this case, there is a partial what do I call it? There's a partial ionization, meaning not all the hydrogen is used. So what is going to happen is that there will be hydrogen ion. One of the hydrogen ion will be used, which will now be attached to CH3 COO CH3C COO-. So in this case, there's a partial ionization. You can see there's still hydrogen attached to this, right? Why you are having just one hydrogen? If it's a full or complete ionization, there should be no hydrogen here. So this is the difference. These three are strong acid. Why?